So thanks everyone today for your attention. Thanks for being here. Really exciting to be at JPL. We are ontologists. We go to the Incosi International Workshop and we tell everybody we're not being specific enough, and we're right. We're not being specific enough in our communications. But I want to pause a little bit today because we've heard a lot about different tools, different languages, different environments. But what do we want to do with these ontologies? Picture in your mind the perfect ontology, the magic ontology that can do anything you want it to. It's beautiful and it can be translated into any language. What would you have it do? We do data representation and system analysis, and we do it by hand. But I want to talk about what we could do today. You know, I didn't include the Empire demos and everything. This is what are the next steps. All right. So we're going to talk about building the next iteration of ontological utility. Once these are functional, once they can do what we want them to do, what's the next steps? So a little bit about our organization. We're a consortium of 8 universities throughout the state of Alabama, the Alabama CubeSat Initiative. And at one point in time, we were the largest collegiate satellite program in the world, and we've got a variety of projects. And a couple of those projects are listed below. And the one that we're talking about here today is Empire. I have no idea why Auburn's thing showed up like that. But for each of these projects, we have to answer the same questions. And if you're a project manager, you probably have gone through this too. Who are we? What are we doing here? What are we building? What's our schedule? How will we manage our resources? Who's in charge of things? What's our deadlines? Who are our teams, partners, contractors, vendors? This is an exhausting set of tasks that is generally organized into these work products. They're codified there. And the common way that these get created is through older people. These people have experience, they have the knowledge, they've been doing this a long time. And so you get a project concept dropped at the desk of some experienced older person working there, and they will take all that information, they'll distill it into some foundational documents, a project management plan, a ConOps, system engineering management plan, cool. And then they'll disseminate that information, and then that information will be used to create additional sets of documents. And we as model-based systems engineers know that DBSE is kind of an older paradigm, but this is still how it happens in industry and, as our colleague Joe earlier was saying, in academia as well. And there's better ways to do this. So we started to think, this sucks. We have to do this over and over and over again. Can there be a better way? We said, okay, ontologies are really useful. We use them for spacecraft. We've done a lot of other work with them. So what else could we do? Well, we know the 4 pillars of model-based systems engineering: architecture framework, process framework, ontology, and modeling language. Sure, we got SysML and UML and all kinds of MLs. What if we could take the ontology and build the architecture framework and the process framework into it, and then query that ontology to get what we want? And as kind of a visualization of this, on the left, you have the traditional way where that project leadership will have some mental model of what the system needs to be and do, and they'll filter your architectures and your stakeholders through that, and then they'll create the foundational documents. But instead, what we could do is look at an ontology. We query that ontology, we interact with it, we tell it about our mission or project, TurboTax style, where it's asking questions of us, and then it's making the semantic connections inside, and then it generates the documentation. So, okay, if we get this right, we can now take a process that takes 3 to 5 months to concept define or to conceptually define an upcoming project or mission and turn it into 30 minutes. So now we have our goal. Now we have an idea. What else is involved here? So when talking about the ontologies that could be used, the language matters, the structure matters. And if you're looking at binary predicate ontologies, this is going to be your RDFs, your OWL, your OML. And you're looking at a 2D space, you're going to see some version of this. And this is just an example. This is one domain ontology that we've worked with and presented, but it can look like this, and you're all ontologists and you're familiar with this. So when considering the ontology and our ultimate goals, we needed to define the problem. And our first problem is that many of these ontology language they restrict your ability to express as much as you want. If you want to relate more than two things, binary predicate, you have to use reified relationships on top of reified relationships on top of reified relationships. And every time you do that, you get a higher degree of coupling and complexity just in your language utility, which is difficult. So if you want to express really advanced mathematical concepts, you need first order logic. And that is ultimately, bury the lead here, where we're going. And two, these sub-symbolic or connectionist AIs, if we want to apply these to, say, human-rated vehicles, the cost of being wrong is too high. And any kind of model that's built using a neural network or some kind of system that you have to train through reinforcement learning cannot make decisions that are explainable and correct. It'll make decisions, but it cannot tell you how it made them. And you can't go find the answers either. So if the cost of being wrong is too high and you can't explain how your decision's being made, it's probably not a great strategy for widespread implementation throughout your organization. And finally, a tool that facilitates both SE and project management, highly coupled organizations of information material, does not exist. SysML, as wonderful as it is, does not inherently facilitate project management. Jira, Teams, Confluence, Monday, Rike, Trello, whatever, they don't inherently facilitate systems engineering. We're doing both of these things. Why can we not do them at the same time? If you have your magic ontology, what do you want to do with it? So characterizing the solution space here, we've got to have the ontologies, and we've got 1,000 of them in this room. Which one is correct? They're models of knowledge. All models are wrong, but some of them are useful. So we're focused on what are the most useful ontologies built in the most useful languages. And for us, that's first order logic. We're doing set theory and system engineering formulations, blah, blah, blah. A software platform is needed. This is Empire. We're not showing the demo today. I've got it. DM me. I'm happy to show you more material. But I want to convince everyone here that we can think bigger. That's my point. It's not just data representation, and it's not just stuff we do by hand. We can organize this material so that if we define a requirement, it generates the architecture, it generates integration information. You can generate documentation from a set of complexly related pieces of information. It's all possible. And if it's going to exist, it needs to be able to generate the functional flight software. It's got to be able to make the documentation because your engineers hate making it. And it's also got to give you verification procedures. So your project managers and your systems engineers are building the model, which then generates the verification procedures that your discipline engineers then go out and do. Your electrical, your aerospace, your mechanical, great. So here's some acronyms. This is the last slide. Empire stands for the Engineering Management Platform, or integration, realization, and execution. Fancy words, but we mean them very specifically in the INCOSE sense of those words. The UOS, the Unified Ontologies Foundry, not the UFO. This is the organization that is creating these first order logic systems engineering set theoretical formulations of ontologies. That kind of ontology doesn't exist. It's very, very complicated. It is not the most user-friendly, but that's not the point. The point is the software platform that the ontology enables. We don't want people looking at the ontology. We don't want you doing stuff by hand. If we can just agree on a set of concepts that are most useful to our project managers, systems engineers, and discipline engineers, then we can make a platform that is useful to you that generates all this information. And finally, the UOS is the set of ontologies. Our TLO is roughly BFO based, but there are some problems with the BFO that we have communicated, and I'm sure we're all aware of to different extents. Mid-level ontologies, we are creating those with slightly different first order associations of what is a what's the metadata, how do we handle annotation properties in first order logic, all that kind of good stuff. So we're building Empire. We are providing Empire a deployment to JPL's F Prime working group in May for use on their next Mars helicopter concept development. This is primarily intended for the software engineers to use, but as I was mentioning earlier, the software engineers are not going to care about the project management and systems engineering information that Empire generates as they're just doing what they do on their own. So we're also looking for additional folks at JPL that we can show the rest of the information that's being created. So to be clear, if we have semantics in the sense of meaning built into our models, putting one set of information in the model can generate the rest of the information in a self-consistent way. And just by spending 5-10 minutes in the model, you can then get several hours worth of information represented, and you don't need to verify that it's all self-consistent. Let's think bigger with what we can do with our ontologies, define that, and then work backwards in order to realize the future that we want. Thank you.